All right. Yeah.
Right. Awesome. Well, we're really excited today to have a special guest with us, John DeGoes. John is, among many other things, the architect of ZIO, and I think has been a mentor to me. I know a mentor to Kit and a lot of other people in the community. And we kind of wanted to do two things today. One, we just want to talk about like contributing to open source in general and why you might want to do that and how to do that, and then kind of go from talking to action and kind of play the role of first-time contributors to a library, ZIO Schema, which we're not entirely actually playing the role of because neither Kid and I have contributed to this library. So we're going to get the chance to learn a little bit about it from John, and you all will too. And then we'll actually kind of go through and we'll try to actually do a PR, or at least make a good start and kind of do the lion's share of the work on it. But to kind of step back maybe to the why open source, I think it's a great opportunity for you to both learn and get mentorship and also get exposed to things that maybe you wouldn't get a chance to get exposed to in your day job. So like for me, before I started contributing to ZIO, I had done some stuff in Scala, I did kind of some stuff on my own, I'd done some stuff in Python, but I hadn't really kind of either contributed to an open source project or like done functional programming to a serious library. And so it's a really great opportunity for me to kind of learn there, and really opened up a lot of other opportunities for me. And I think it's also something where you don't need to be nervous about doing it. Like, I think it's easy to feel like, oh boy, like all these people know so much and I don't, and like, how do I go about doing this? And I actually wanted to share with all of you, if I can find it here. Here, I'm gonna paste it into the Discord. So this was my very first PR to ZIO.
Oh, can you share it as well, just so for the?
Yeah, I think I just pasted it into the Discord link.
Oh, I mean your screen, just so that.
Oh yeah, yeah. Sorry, yeah. Let me do it right now.
For posterity.
Yeah. So this was this issue for each part n should not use more than n fibers, which, okay, makes sense. This is like the bounded parallelism operator. You're supposed to only do n, so you should actually only do n. And what was funny about this is it was based on this issue where someone had sketched out that, okay, this is not working. And they had this, the general idea would be something like, and this isn't even a very general idea, this is like literally a proposed implementation here. And despite basically someone having sketched out the implementation, my very first PR to do this, sorry, let me just go back to the link here, involved 19 different commits. If you scroll down here, you can see lots of comments. Itamar got involved as well, a little bit. Freskog. Here's, I think, Kai jumped in at one point. John. So lots of like work for me to do. It was probably like in retrospect a like very simple PR, but I got a lot of support from a ton of people, and then I had like a great experience with it, and I kept doing it, and hopefully I think that was like good for ZIO overall. It was great for me. So I really hope one of the things you take away from this is don't be afraid to contribute to either an open source project in general, or especially a project in the ZIO ecosystem of we're here to help you, we're here to answer questions you have, and we want you to be successful. And I think as we go through this, we'll also kind of go through a little bit of like some of the like best practices for doing this. I think if you go back to this like original issue here, one of the things you see I did is I kind of said like, okay, this seemed pretty simple because the person had literally sketched out implementation, so I thought this would be a good first issue. And I said, hey, I'll work on this. So that's like a really good thing to do, of kind of letting other people know like, hey, I'm gonna work on this, so no one kind of does the same thing. And then in this case, I guess I felt like I had enough with the implementation done to do initial pull request, even though clearly I had a ways to go from there. And I think that's another good thing of like, depending on where you are, if you feel like you have questions and like you'd like to work on it, but you don't know enough, you can ask questions in the issue. Or if you feel like, well, I can kind of make a college start at it and then, but I have open questions there, you can open a PR and kind of get feedback from there. So it's a very collaborative process. But that was me talking a little bit. So Kit, I don't know if you want to talk a little about your experience, and then John, maybe you can talk a little about your advice.
Yeah, sure. I mean, yeah, I for people that don't know, I joined Cyverge, I think only a month and a half ago. It feels like a few years ago, or I've certainly learned a few years worth of knowledge, and in the last couple months, and a lot of that has to do with just doing open source stuff, like having to write complete solutions to sort of complicated problems. You can enter this very virtuous cycle of progress because you're motivated. You want to get something done to release to literally, thousands of users and make them all happy. You want to impress your peers. You want to learn from people. It's a very powerful way to learn. I mean, just talk about like the selfish aspects a little bit of contributing to open source is that you get to learn a lot. And I mean, you see all the people commenting on this. Just talking with like I talked with Adam in private about just his experience getting started, and I had no real conception that it could have been possible that this was his like first bona fide full-time software job, because he's so good at coding and designing and thinking through problems. And I mean, it seems like he has decades worth of wisdom and experience. But I think now that I've been in this sort of world for just like a month and a half, I realize like, no, he has like 2 years of working on open source full time, and you learn really quickly when you do that stuff. Just seeing the habit of sort of Adam, like that thing that he said, right? I got this. Like that is something that he posts all the time. Like, let me take a stab at this. I think I can, in the past, I'm sort of a perfectionist. I'm afraid of failure. I don't know. It's like, okay, this seems complicated. I don't know where to start. So I kind of never begin, right? Kind of skirt around the edges of hard problems. Like, let me read a blog post. Let me watch a video. Let me poke around. Just like removing that barrier and just starting, you learn, you're going to struggle, but you're going to learn so much so quickly. And most of all, you're going to realize that it's actually very possible to do things, and you're going to build a lot of confidence very quickly. And I think, especially doing open source, like people are grateful to have you. Especially, I don't, John and Adam and me. Like, if you want to help us build some software that we can all use, that's awesome. I will happily help you. You can only do so much. There are only so many hours in the day. So yeah, I think it hopefully can be a cool like symbiotic relationship, and you get yourself out there. It can lead to jobs. Don't want to make a pyramid scheme thing out of this, but like that's what happened in my case. I'm kind of was able to get the job I wanted by doing the work I wanted to do, which was it's kind of cool. And yeah, it's been amazing. But anyway, enough of that. I will pass it over to John, and then we can sort of talk about the high level of this and get into the actual meat and potatoes.
Yeah, I want to echo just some of the thoughts shared by Adam and Kit, that one of the great reasons, I think the greatest reason to do open source development is learning. Because especially in an environment like ZIO, which I think has very much a culture of mentorship, we want everyone to learn from everyone else and sort of become as good as they can be at writing functional Scala. You get the support of people who have been there and done that, people who are willing to pair with you if necessary. Like Kit mentioned earlier when we were meeting beforehand, he's ready and there to pair with anyone who wants to work on one of these issues. I've done that myself. I know Adam has done that. We're all here to help you succeed. And what you can gain from working on an open source project is the help of someone who is very experienced, who has worked on the same software before, who knows how to apply both techniques from FP as well as features of Scala. So let's use this feature or that feature of Scala in order to solve specific problems. And then I think beyond all of that, you get code reviews. You get code reviews from lots of people, and you saw some of the reviews that Adam got, very detailed, constructive feedback, all 100% constructive, very detailed, actionable, that help you become a better software engineer. And it's hard to pay for that kind of feedback. It's hard to get people to review your code at work. The quality of those reviews is inconsistent, but you get all that feedback, and that's because you have a community of people who are very passionate about making these open source projects the best they can be. They want to help you be successful. They want to help you write the best code that you can. And so you get a ton of actionable feedback that helps improve you as a software developer. Also, one of the points I make is that in your day job, you are often forced to cut corners. We all are. It's just a fact of life. We have software to ship, and we have to make the right choice for the business. Sometimes that means shipping stuff that is not according to best practices. There's no shame in that. That's just part of life. But in open source, you have a chance to do things the right way, exactly the right way. You don't have to cut any corners. Why? Because no one is paying you to do this. No one can set any deadlines. It's just do whatever you want, however you want to do it. So you really have a chance to sort of take everything you know about best practice software development and put it into action. And even just exploring that landscape of that alternate universe in which you write only fantastic code and only the code you want to write, it can be a joy, but also you can take lessons from that back to your day job. Maybe you can't do everything exactly perfectly, but you're more familiar with some of the trade-offs. And when you do make a compromise, when you do cut a corner, you recognize that and you're like, okay, I am deliberately cutting this corner. I know I might not do this if I were doing this in the ZIO open source project or one of these other ones, but I'm making this choice, and this is why it's suboptimal in this case. So I think beyond the learning benefits of open source, which Adam and Kit have spoken to, there are also career benefits, I think. And I don't want to overplay those too much, like Kit said, but there are tremendous career benefits because you get your stuff out there and people see that, and it provides an opportunity for you to talk about your work. Other people will see that. Your potential employers will see that. Developers, when you go to interview, one of the first things people do is check out your GitHub resume. It is a resume, and that code speaks. And if you've done some interesting work on one of these open source projects, that can be a foot in the door. And especially if you've not done functional Scala, if you're trying to get in to that industry and have a really nice job using ZIO or some other functional programming library in the day job and get paid to do that, then having some experience, some proven experience on your resume can go a long way in de-risking it for a potential employer. So it's something I recommend all the time. So in summary, contribute to open source. You're going to have a fantastic experience, hopefully. You're going to learn a ton, and you may even boost your career. I would hope that it ends up boosting your career.
Awesome. So with that, maybe we should shift gears a little bit to ZIO Schema, which I know is a project that you had posted about recently of something that's both important for the ZIO ecosystem and other projects, as well as something you're personally working on and looking to get additional contributions on. So maybe tell us a little bit about the project.
Yes, I am all too happy to do that. I am very excited about this project. Let me share my screen.
Oh yeah, let's see. Should stop my share. Okay.
All right, everyone see this?
Mm-hmm.
Okay, fantastic. So before I talk about ZIO Schema in particular, I want to talk about a concept in functional programming real quick. That is reification. Reification occurs when we take something, some construct in the language that is not a value, and we create a data type that models that thing so that we can turn it into a value. It comes from the word real, and it means to be made real. So we take something that's not really real in the sense that it's an ordinary value. You can stick it in a val, you can pass it to functions, you can return it from functions, and we reify that. That is, we turn it into a value. And in turning it into a value, we open up a whole universe of possibilities, as I'll explain here in a second. The first example that I would like to discuss is functional effects. So functional effects, like ZIO, what they do is they take statements and they reify them, they turn them into values. So statements are things like this. And in an ordinary program, these are not values, these are side-effecting expressions. And so we can't take these things and we can't store them into values, we can't pass them into functions, we can't return them from functions. And what libraries like ZIO do is they say, oh, well, what we're going to do is we're going to turn these things into values. And you do that by wrapping it in one of the ZIO constructors, and now these things become values. And because they become values, we have the opportunity to compose them in more ways than just sequentiality. So we can always take two statements and we can compose them sequentially just by listing one after the other. That's the only way we can compose statements, is sequentially. But with libraries like ZIO, we can take two tasks and we can compose them in parallel. Or we can write combinators like retry that will return new tasks which retry the original a certain number of times, and so forth. So the act of taking these statements and turning them into values opens up a world of transformation and composition possibilities that didn't exist before. And they give us tremendously more power than merely the ability to compose two statements in sequence, which is the only thing we have from ordinary statements. In a similar fashion, the next example I would like to give you is optics. So optics are really interesting. And what they do is they take the concept of a field, which is not a first-class construct in programming languages, and they reify that. So here I have a case class, which would be termed a product type in functional programming. And this case class, it has two fields, one called name, which is of type string, and another called age, which is of type int. Now, the language has very special support for accessing fields inside case classes, and we do that using the dot syntax. The problem, however, is, if you want to consider a problem, is that this special syntax is a language feature. It's a special purpose language feature. It's not real. It's not reified. And implications of that are that even though there does exist a concept of a field inside Scala, because that field is not a value, we cannot create operators that combine two fields, an access of this field inside this structure and an access of this field inside this structure. We cannot create an operator that combines those together to allow us to access something that is nested. And the solution to this problem is to reify this, that is to invent something that's called an optic. And an optic is nothing more than a data type that models as a value the concept of a field. And not just the concept of a field, that would be called the lens, but also the concept of one of some number of terms of an enumeration. So if we have an enumeration that contains 10 terms, for example, 10 cases, then something called a prism can reify the concept of selecting one of those prisms. And then there's another thing called a traversal, which can reify the concept of selecting all the elements of a collection. So what optics do is they allow us to take things which are not first-class concepts, namely the concept of sort of drilling down into a field inside a case class, or drilling down into the cons term of the list sum type, and turn that into a first-class value so that we can start composing these things together and transforming them in a first-class way. That gives us tremendous power. Optics solve a lot of problems in functional programming. They take very gnarly code that's difficult to work with, like nested case class copies, and then iterations down deep inside on elements of a collection, and they turn that into beautiful, absolutely beautiful, very easy to work with, very easy to maintain logic that's very, very close to the business logic and doesn't have a lot of the low-level mechanics that come into play when you're working with applying modifications to deeply nested immutable data structures. So the concept that is relevant for ZIO schema is a schema, and by schema I mean the structure of a data type. So if we have a case class here, actually, why did I just delete that? I need the exact same one and maybe one other one. We have a data type here called person, and this person, we can make these fields here into first-class values by using optics. But what about the concept of the structure of the person data type? And by structure, I mean, okay, this is a data type whose name is person, and it has two fields, and each field, one field has the name, and the other one has the name age, and the one that has the name age has type int, which is additional structure, and the one that has the name has the type string, which is additional structure. So that is a high-level description of this person data type. You can see here, looking at the code, Scala understands that. We create this data type, and then it generates the JVM bytecode necessary to model that. But that concept of the structure of this data type, it does not exist as a value. It's not real. And what ZIO Schema is an attempt to do is reify the concept of structure for data types. And not just case classes like this, but also enumeration. So if we have some sort of sealed trait payment method, and there are a couple of different choices for a payment method, such as a credit card with a number and so forth, all of which extend payment method. And this is an enumeration. It's a sealed trait, but in Scala 3, you would call this an enum. So I'm going to aggressively forward-looking call this an enum now. It's an enumeration that has one case right now, but in theory, you're going to have multiple ones like wire transfer, ACH, and so forth, all of which would be subtypes of payment method. This here is called a sum type. So this is a product type. This is a sum type in functional programming terminology. Together, they make up algebraic data types. So algebraic data types are those that are formed compositionally from product types, case classes, and sum types, sealed traits, or enums in Scala 3. And all data in the world, all data in a functional programming application can be comprised from sums and products. So it's all ADTs. And what ZIO Schema is trying to do is give us a way to reify these two distinct types of data. So a way to reify products, case classes, and a way to reify the sums, the sealed traits. And you do that by the concept of a schema. So a schema is actually a value. And schema has a single type parameter that represents the Scala type that is described by that schema. So in this case, I have a value that represents the structure of this person data type. And I might also have another one down here that represents the structure of this enumeration. Now, why would we want to do this? Well, it's the same reason we would want to make statements values or make fields values or make terms inside enumerations values. It's so that we achieve the ability to write operators that transform these values, as well as so we can write operators that take two of these values and combine them into one. And then even further, in the case of schema, schema is a very powerful value. If you have a value like this that describes the structure of a data type like person, then it opens up the world into a host of new functionality. And I'll give you an example. So if we have a way to describe the structure of a person data type, then it's possible for us to introspect on that structure and then automatically write a codec which can translate from JSON to this person data type, and also translate from this person data type into JSON. So that can be written in ordinary userland code. All you have to do is pattern match on schema and handle the appropriate cases, and to write a translation sort of step by step for all the different fields inside that data type. And you don't have to use any macros, no metaprogramming, no code gen. You don't need any of that. All you have to do is pattern match on a simple first class value in order to generate a JSON schema. And it doesn't stop there. If we have a schema for person, not only can we automatically generate a JSON codec, but also we could automatically generate an XML codec, or a protobuf codec, or a CSV codec, or an Avro codec, or Parquet, or any number of other file formats. We could generate all of them from a single description of the structure of that data type. And that's enormously powerful. And not just could we do that, by the way, but we can do other fancy things. Like if we have one schema over here representing an older version of a data type, and another schema over here representing a newer version, it may be possible in some circumstances for us to have an operator that does a diff between these two schemas and says, oh, in order to upgrade this values that look like this into values that look like this, we have to apply these series of transformations. And those transformations could be automatically derived, or they could be provided by hints from the user. In addition, having a data type like this allows us to do fancy things at the level of generic data. So we could actually do diffs across arbitrary data structures, which is very powerful. The ability to diff across arbitrary algebraic data types, more or less for free, comes from the ability to treat schemas as a first-class value that you can pattern match on, and you can write ordinary userland Scala code to do whatever you want. So these are some of the applications for schemas. You can get codecs for any supported protocol, diffing, patching, merging, and other generic-based data operation or generic data-based operations. You could do migration of data structures from one schema to another compatible schema. And very interestingly, you could actually derive arbitrary type classes for anything for which a schema exists, which is something that's not done yet, but certainly will be done in the future. So basically, if you need to do anything with your data structure that involves serialization, deserialization, persistence, transporting it across the wire, or storing it in a file, reading it from a file, or getting arbitrary functionality like equals, ordering, hash code, all that stuff, encryption, decryption, any of that stuff, it could be derived from a schema. So a schema is like the holy grail for data. It unlocks a whole world of power that once you enter that world, you now have access to a gigantic array of tools that come for free from that first class concept of schema as a value. So I recommend ZIO Schema is not unique in this regard. I know Chris Nuttycom did some work on a library called Xenomorph, and Valentin Kazaz did some work on a library called Schemaz, or Schemas. I'm not sure how you pronounce it, but those two libraries would be good resources to check out. There's been some stuff like this done in the world of Haskell as well. Look for generic data type programming and concepts like that. Anyway, that's what we're trying to do here with ZIO Schema, is give you, basically reify the structure of data types as a first class value called a schema, as well as automatically derive schemas from your data type. So that's something that's already built in and it's working. So if you have your own ADT, don't think that you have to write a schema for it by hand, because we can auto derive that using macros in Scala 2 and metaprogramming in Scala 3. We can do that for you. So you never have to write one of these things by hand. But once you have one of these things, your days of having to write macro-based code are over, okay? Once you have a schema, you don't need any more macro-based code at all. And that's a big advantage over the dominant way of solving problems like this. Right now, everyone writes a JSON library, and that JSON library will be able to use macros to derive JSON codecs for your data type, and then they write an XML library, and that XML library will be able to use macros to derive XML codecs for your ADTs, and then on and on and on. Well, we have like sort of the N library problem, where N library authors are all writing macro-based code in order to solve the problem, or worst case, they're using a library like Magnolia that has that macro code for it. But in theory, all we really need is one library. We need one library to represent schema as a value. And given that, an infinite number of people can now create derivations from schema, and they never have to know anything about macros whatsoever. All they have to know is how to pattern match. And a lot of people already know that in Scala. So this is opening up the floodgates to sort of radically new functionality. And also from a library author perspective, this is one of the cool things in the ZIO ecosystem, is that from a library author's perspective, you can request that some data type have a schema for it. So if you're depending on ZIO Schema, you can just say, I can support any type A for which there's a schema. And suddenly that gives you the ability to support a huge number of protocols. So JSON, protobuf, XML, and just on and on and on. You can support all protocols in existence. That enables a level of power and expressivity that is not common in the Scala programming language. You might find a library that supports JSON, but you're not going to find a library that allows you to use JSON or XML and Avro and Parquet and CSV and all these other file formats for free. You're not going to find that. And the reason is it's just too much work to support all of them. But the concept of a schema gives these libraries a way to suddenly support all protocols out of the box without any coding whatsoever. So that's why I'm really excited about this library. Now let me do a very brief tour before I turn it back over to Kit and Adam.
Could I ask a high-level question?
Yeah.
Eagle actually had one in the chat, which was about JSON API schemas? Is that I'm sure that's probably possible as well to generate a JSON API schema, and things like this, right?
Yeah, it should totally be possible. Yeah, it should be
Okay.
possible to generate JSON API schema from your
And
data types.
what would the are there any performance trade-offs versus the pure compile time approach of using something like Magnolia or Shapeless or a bespoke thing, or is it really the same, like the Scala 3 mirror, compile time mirror, um, approach? Is there anything, or I mean, this would be potentially generated at compile time as well, so.
So the schema data type would be generated at compile time. Then how you handle that schema data type could be, you could handle that in a performant way or maybe a less performant way. That would sort of be up to you. But Dan Harris has been working with me on making a lot of this very high performant. In other words, basically providing sort of high performant back-end machinery that you don't have to use if you don't want, but it will exist there. It will be utilized, and it will enable you to do things like serialize and deserialize without any additional allocation due to schema.
Mm-hmm.
So that's where you want to be. You want to be at that point where you could do serialization and deserialization without any overhead that's due strictly to the schema data type. And thanks to a lot of work, by Dan Harris and myself and a few other people, we're getting to that point. We're almost there. So in the end, I don't think that the average application will pay any performance cost in order for using this feature, even though it will be possible to do, I would say, fairly naive implementation that might be slower than something that's handwritten. For example, if you did a naive implementation of equality for a person here that uses maps and all that stuff, then it would probably be slower than something that you could generate at compile time with metaprogramming, because you can generate arbitrary code. So there's no limitation to how fast that can be.
Awesome. Thanks.
Yeah, and by the way, that would be welcome contribution, generating a gen, because you could generate a gen from anything that has a schema. So that would be fantastic if we supported that. And as part of the ZIO ecosystem, ZIO test being part of the ZIO ecosystem, it would totally make sense for us to be able to generate a gen for anything that had a schema. That is possible. All right, so let me dive in. Let me go ahead and close this. Gives you a sense for why this library exists and why I am unreasonably excited about it. Now let's take a look at how the sausage is made. So this is the core data type. It's called schema. Schema here is invariant in this type parameter A by necessity, because a schema basically allows you to derive operations that produce an A, but also operations that consume an A. And that imposes limitations on the types of transformation operators and composition operators that we can provide baked on schema. The ones here are actually a fraction of the ones that you could actually implement. We just have a few. We have zip, and we have this thing called transform. This is the equivalent of map. So given a schema of A, you can actually turn it into a schema of B by supplying a pair of functions. So unlike map, by the way, if you were to use map to turn a schema A into a schema B, you would only need a function from A to B. That's what map is defined to be. But to do this with schema, you actually need two functions. You need to go from the A to B and the B to the A. And if you can't actually do that in all cases, you could use transform or fail, which allows you to fail in either direction. And here's an isomorphism. This here is a partial isomorphism that allows you to say, oh, not all cases map to all cases. Zip just allows you to take two schemas and zip them together. So this is a sealed trait. It is an enumeration, which means you can exhaustively match against all schemas. And there's not very many of them. There's only, well, actually, there are a few. Thanks to the performance stuff, there now are a few, but you don't have to support all of them. In end user code, you can actually support a subset, because you can treat all of the case classes and all of the enums as being sort of uniform if you want to. But if you want to do super high performance stuff, then you need to special case all the different case classes and enums. Anyway, the main ones are records. So this is a record. And sequence. So this is things like a list. Records are case classes. Sequences are things that are list-like. Enumerations are sealed traits, basically. Transformations are how you take a schema of one type and transform that to a schema of another type. Primitives, I'll talk about in a second. Optionals are just sort of special case support for option because it's a common Scala data type. And many protocols like protobuf or JSON, they have special support for optionality. So it makes sense to bake that into the protocol rather than emulating it with transform. Fail, you can produce a schema that can't actually do anything. So failure is baked into this description language. Tuple and either, so two other fundamental ones here. And then you have specializations for case classes and enums that exist only for performance reasons. But all of this is really all of you need to support if you're a library author and you want to derive stuff from a schema. The interesting one here is primitive. So this handles composition. Record and enumeration and sequence handle composition. This is how you build up support for all ADTs, because you have the ability to model products and sums and also collections, because it's nice to support those in a way that doesn't use sums. But how about everything else? How about the leaf types in your application? Well, this library has a concept of a leaf type. It actually supports all of the primitive types in Scala and Java as leaf types. The big decimal and big integer, which are important for many applications. And then it supports all of the Java time, all of the important Java time structures, which are important for many applications. So this is what you have to support. When you're implementing support for a new protocol, you need to be able to handle these. Now, just because you need to be able to handle them doesn't mean you need to be able to handle them losslessly and one-for-one. For example, JSON cannot encode. It doesn't have a native representation of all these Java time data types, but you can convert into strings. And then you can back convert them from strings into their underlying Java time data structures by using transform or fail. So this guarantees that for protocols or databases or whatever that do support these richer types, you have baked in support in your application if you have a schema for that data type. But it doesn't prevent you from encoding all this information in a poorer protocol that doesn't actually have native level support for any of this. And then what we have right now is a concept. This is going to change organization a bit. We're going to bump out JSON into its own project maybe, its own project, and protobuf into its own project, so as not to contaminate all of this code with that stuff. That way you'll just be able to depend on the jars that you want in your application. Do you want to support JSON, XML, Avro? Just add those specific jars in order to gain those support. A codec here generically encodes the concept of a codec. So codec here has no type parameters, which is different than any other codec out there in the Scala ecosystem. This type of codec says, given a schema, it is capable of generating an encoder for any schema. And also given a schema, it is capable of generating a decoder for any schema. This is a very powerful notion of a codec. It says if you can describe it in terms of a schema, then we can serialize it and deserialize it. And this codec here is now used by ZIO Redis, and it's in the process of being used by ZIO Redis. And it's how Redis will support you being able to store protobuf or JSON or whatever you want in Redis without any userland code. It's being supported by ZIO Web. This is how ZIO Web is going to support payloads. Basically, in ZIO Web, you don't have to do content negotiation. You don't have to say, I'm going to support JSON. You just support everything. You support the whole universe of possibilities. All you have to do is have schemas for your data types, and then those are translated into JSON or XML or whatever else the client requests that you're willing to support in that ZIO Web API. And then ZIO Flow is actually using this, or about to use it. I think it actually is using it now. And it's using that to describe basically the set of all possible data types that can be persisted inside of a ZIO Flow workflow. So ZIO Schema is really, it's the foundation of sort of a next generation line of ZIO libraries that are going to have a lot of power thanks to all the free stuff that they get from this library here. All right, any questions?
So if I have a custom data type of my own, I define whatever a animal, then the way I would support this here is I would use that transform function to map that back and forth to one of the, or a collection of these primitive types. Is that the right way to think about it?
You could, but you could also call this gen function inside derived schema. And let me show you how that might look. So let's say that you have your own data type here. then inside the companion object for animal, you would say that you would make this an implicit val, schema animal, and you would say derive schema gen for type animal. And then that would use macros to automatically derive an animal, assuming, of course, that everything that's inside all of the subtypes of animal has a schema available for it. And there are lots of schemas available for all the standard types in Scala. So it's mostly the stuff you have to worry about your own data structures and making sure that they have a schema available for them.
Will it recursively derive? I'm not sure if like if animal had subtypes that relied on some other type, will you need to place it in every like nested sealed trait or every nested case class that extends animal? Will they each need their own
think
derived?
it does recursive derivation. I think it does recursive derivation, but it's supposed to work like if you define your own schema for an intermediate, it'll use that rather than automatically trying to do it. That's the idea. I think Magnolia might have a few bugs around that. Magnolia is currently being used to do this derivation. And then if you want, of course, if you like writing boilerplate code by hand, then there's nothing to stop you from, like Adam, like you said, writing this yourself. What you would do is you would just use, actually there's some helpers to make it maybe a little less boilerplatey, but like there's this case class n helper function. Okay, so there's like zip, 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 but there's also some case class functions. I don't know, maybe there's not. I thought there was.
But that automatic derivation would require that it be a combination of sum and product types. If I just have a class animal, then since it's not defined
Right.
as PDT, it's on me to translate one of these things.
Exactly. And the way you do that is you use the schemas for the pieces inside there if you want, and then you call transform or fail on there to go from whatever that is, because you can zip these things together and you can combine them in alternation. You don't have an operator here for that, but you can combine them in alternation with one of these things. Then you just, after you end up doing that, you transform or fail that to get the target type.
Yeah, last week when Adam was talking about Prelude, we sort of talked about how the same shapes and structures pop up here and there. And I mean, this is another great example of that of, okay, here's another data type that has zip. And this one doesn't have, as you were mentioning, because it's not covariant, it doesn't have little plus, doesn't have map, but you get this invariant operation that pops up a lot, the transform, where you provide both a map and a contra map to go both ways, which you see a lot in codecs and things of this nature, where you need to.
That's exactly right. And this is the one that's missing. Right, but it's not really missing. It's just there's no operator for it. Well, now there is.
and I like, because I've seen you do this before in the transform or fail. I like these because these are kind of primitives, and on top of this, you can build the nicer ones like transform and transform or fail. Both turn into the same sort of base level description, reification of this failure type, right? With the non-failing transform, you just wrap the outputs in the right. So I think you've mentioned this before as well, where you want this sort of orthogonal series of foundational elements, which then you can sort of get a nicer API as you build on top of. But the most base ones will have to sort of be complicated enough to fulfill everything you want to do, and can get a little,
Yeah,
you can't have the base one not be able to fail if you want to be able to fail. Yeah,
exactly. All right, any other questions before we turn it over to live completion of a random ticket? Well, not random. You're prepped, right? You cheated.
Yeah, let's
have it open. I don't think I actually, we didn't read it. So we know true. You will all see non-simulated ignorance as we ask real questions. Adam, do you want to share your screen?
Yeah, I'll share my screen here.
And I think we have a VS Code live share, which is how Adam and I have been working on some stuff recently. So it is also.
Yep. So got issues here. So I think the one we talked about was this one, right? Add a generic data representation.
Yes.
So
I'm going to be totally silent and pretend pretend you're two new contributors, right? And if you ask me a question here, that would be like you asking on the ticket.
All
Gotcha.
right, perfect. So we should have a generic data representation, generic, that mirrors the schema hierarchy such that we can convert an A and a schema A into a generic. And so we're going to be able to take a schema and given a value, we can turn it into this generic thing. And then given a generic thing, we can either, I guess, fail with a string, or we can get that thing back. So it seems like this generic thing is kind of like an untyped version. It's almost like any where the only information we've retained is that we can possibly transform it back into a schema with this thing.
Yeah,
At
is
least
it just
I'm reading
type
this.
erased, sort of? I guess this is where I might ask for typing in like some maybe like what's the intention? I think that's kind of maybe what's missing from the issue for me is like what's the goal, right? Because sometimes if you know like the concrete purpose, you can kind of reverse engineer some other answers to other questions. But and also maybe we could just ask like, yeah, is that intuition that Adam said aloud? Is that correct? That's kind of like a type erased mirror, bizarro world of schema.
Yeah, exactly. It's a way to describe the entire universe of possibilities for schema values, and do that in a way that you can interact with the data with its structure baked in. So ordinarily, like there's the schema over here, which tells you what the structure of the data is, and then there's the A over here. These could be regarded as a relational database where you have the schema, the table structure, and then you have the actual row, the data inside it. And there's a separation between the data and the schema. Well, if you switch over into a world of like JSON or NoSQL or whatever, you have sort of self-describing structure where there is no separate schema and data. It's all rolled up into one. And when it's all rolled up into one, it makes certain types of operations a lot easier. Not necessarily performantly, but it makes certain types of operations a lot easier. For example, let's say you want to take two values of type A and compare them to see which one comes first. How do you do that if you have a schema of A? It's not very simple. It's not very simple.
When you said JSON, yeah, I wasn't even, this totally, it's okay. So it's a value representation of a schema. So it's basically like if you squint, it is seal trait JSON, final case class, number, value, big decimal.
It's like a richer version of JSON.
Yeah.
That can express all of what schema can describe as a value. It has its schema baked in, basically. It has its schema baked in. It's a self-describing, a schema together with the raw data. It's an enriched version of JSON.
Okay, that's...
And if you have that, then it becomes much easier to do things like, let's compare two things to see which one comes first, right? If you have a schema of A and you have two A's, which A comes first?
Mm-hmm.
You can actually figure that out, but it's not a simple calculation to do. On the other hand, if you have this sealed trait generic, it becomes much easier.
Another, because I guess the other way to do it potentially would be to convert into the A using the schema from some serialized value, which you presume, well, you already have the A here. I see. So you have the A, but you have no information. So you cannot implicitly summon.
Yeah, there's nothing to summon.
Interesting. What is like, okay, so there's the ordering example. Do you have a concrete use case in mind? Is this maybe for ZIO Flow? Is there like a simple, concrete?
One of them is generic data operations. So equals hash code that's consistent with equals and ordering. So getting that out of any schema of A.
Even in the case where you don't have a type, because you could easily write type classes for generic now.
Right.
Okay.
And so then the second part here, it seems like we're kind of, as you said, we're going to mirror the data hierarchy for schema. And I mean, as you laid it out here, you kind of have like a primitive type, and then you have the two fundamental constructors of sum and product types. But I'm wondering if maybe we're actually going to want to, like we had that primitive type thing we saw before, like maybe this mirror the primitive type and just kind of have all those.
That's right. That's right.
Okay, and I mean, this looks nice. This kind of seems like a nice property here that basically if we take a value and we convert it to a generic, and then we use the schema to convert it back, then we should get that value back. So that'll be nice for us writing our tests.
Copy pastable code, just like your first
Yeah.
PR. Perfect. It's done. It's already there.
I don't promise it's bug free. Other laws should be like equals and hash code should be defined and consistent on generic.
Nice.
Okay.
Yeah. Okay, that's very helpful. So a couple things. Well, first of all, some nice happy feedback from Adrian saying he likes the format. So maybe we could try this again with some more open source repos in the future. I'm enjoying myself. This is really fun. And then also the ticket is, Damien asked or said, the ticket is basically implementing generic record like Avro has, and which gets me thinking, is that sort of what's the inspiration for the name generic? Was there like is there some prior art? That's another good thing I think to have in maybe as questions, like concrete motivation, prior art, stuff like that. Anything you could use to Google and sort of people can answer their own questions, which, I think as an open source contributor, when I was afraid to like bug the person too much with questions. Whereas if there were hints to, yeah, those types of things, concrete examples and prior art, that would be helpful. So is there any prior art here? What's the inspiration for the word generic here?
There is. If you look for like GHC generics and so forth, that's the inspiration. That said, it's not a great name. I don't think it's a great name. I don't think it's a great name. So feel free to rename it if you can come up with a different one.
Okay.
Adam also asks, do we mind actually putting the questions on the issue?
Oh yes, yes. Damien asked that, and that's a good point. I forget my questions. Here after
you
the
know the
video, I will
answers
watch
now,
the
so you've
recording.
forgotten the questions.
Yeah, I'll post a link to the recording and the questions.
Yeah. Well, I think the other thing maybe we can do here is we can follow our best practice of saying we're taking this ticket. So I think comment here. Let's see. Are you?
I don't know. I know what I can pay. That's me. Yeah, no one else can. Hopefully, no one grabs it first.
Exactly. Any of our listeners right now?
Quickly, Adam, quickly. There's 75 people here.
Okay. Boom.
Dibs.
All right.
You licked it.
So then I'm going to go to VS Code here. And all I've done so far is I've downloaded the repository and I've just compiled it and I've run the tests once. So I haven't done any actual work, but I just didn't want us to be sitting here while I downloaded this. And I always find it's good to like compile it and run the test suite once first before you do anything. So you make sure if there are any problems in the future, you cause them and they were not pre-existing. So let's look at the project structure here. So we got ZIO Schema, shared name. Okay, so here's the schema thing. Another thing, and so one of the things I think we're doing is we're doing this code with me feature. So I think right now Kit's here with me. Oh, yep, there he is. And I think, John, you have the link if you want to, but you can also just provide the role of providing Q&A if you want to. So what I find is helpful a lot of times is to kind of work iteratively, and I end up using a lot of those question operators. So like here, so it seems like if we go back to our ticket, we needed to implement to generic, value a generic, and from generic. So I mean, I can actually just like copy and paste those.
Nice.
And so
done.
those that should compile now, other than generic not existing. So maybe that's another good first step.
Mm-hmm.
And so I think actually if I save this now, I think this should compile. That's another useful trick I find is like making sure things compile as I go. Okay, and then if we go back to this, we also got like an initial sketch of what this generic thing has to look like.
Nice. Yeah.
And so I'm thinking it might be nice, like, so this two generic methods is going to have like a ton of like, basically I think going to be like a giant pattern match. So I think it might be nice to not have this be in scheme itself here, because right now this is pretty simple and high level. So maybe we could push this here and we could have like a, just do the other way. We'll do def.
From schema and value or something.
Yeah, we can play with the name a little bit, but
Mm-hmm.
yeah. So this will A, I'll take a schema. It's a schema of A.
Yeah, a little hot tip is it's okay to have really bad names when just hacking stuff out. You may not have enough information to
Especially
give
at the
it the right.
beginning, yeah. It's not generic A, that's the point of it being generic. So we don't know what this is.
Nice.
And
So then,
so,
okay, now we can implement it. Easy, easy.
yeah, exactly. So then, yeah, this will be just generic dot from schema and value, self value.
Mm-hmm.
And maybe we can apply a similar way of implementing these methods here. We could just do we want to call it a to type value, maybe.
Oh, I see, I see.
I don't know if that's, this should just be
It returns.
string. Okay.
Mm.
And then this could just be generic dot to type value schema.
And then
Self, right?
yes. Awesome.
Okay, so yeah, we can play with names, but now we've kind of pushed all of our complexity implementation into this new file, which seems like kind of where it should live.
Yeah,
So yeah, go ahead.
Oh, sorry. I was just wanted to talk about maybe potential first steps. I mean, would you want to do the test, the TDD thing, or at least we have that other thing we haven't copy pasted yet? That might be a nice, like to start with. I'm
Yeah.
thinking we have actually, instead of going through all the types, right? We can go through, there's some stuff where we just need to repeat once we have a good foundation. Like maybe just, can we get integers to move back and forth? Can we go build up from there? Can we do a record of integers to go back and forth?
Yeah.
And to simulate another real world event, I'm going to actually just say, I need to grab another LaCroix. I'll be right back at him.
And I'm just using ZIO test here. And I think one of the nice things is I think we just have like some pretty easy conventions for some of this stuff that makes it like just things you don't have to think about here. So we generally just like name the tests based on the data type of testing. So this is generic, so we'll just call it generic spec. And I'm just creating a suite here. And right now I'll just say test M. I'm just going to leave this unimplemented for a sec while we work on playing with this. And so if we go back to this law here, a lot of times what like I figure we're probably going to want to call this law like a bunch of times with a bunch of different like generated values of different types. So instead of like repeating this, it would be nice to factor this law out into its own operator so we could kind of just like call it a bunch of different times. So maybe there are other laws, but let's just start with maybe making a method here, and let's call this like a generic law. And so this is going to have a value of type A. And I think probably we're going to want to move this to using a generator, but maybe let's just start with having an actual value, and then we'll kind of make it more abstract from there. So this says if we have a value of A and a schema, with a schema of A, then we're going to want this to give us a test result. And I think this may be pretty close to like the actual code we can write. We don't quite have the triple equals. So we're just gonna change this to assertion syntax. So we'll say assert that guy is right equal to A. Let's see. Oh, and I need an import here. And then, oh, right, let's just call this A. Okay, so I can do my same, make sure I compile as I go trick. Okay, so this seems pretty nice. And I think maybe what I'll do is I'm going to try to make this a little bit more generic. So I think I'm going to say I've got an R here, and this is going to be a generator of RA. And it's going to return an effect. It's going to give us the test result. And we'll just do check gen A.
And eventually the generator for A could be derived from the schema of A.
Really eating our own dog food there.
Oh man, wow.
Okay, and let's see. Let's see why. Oh, right, and I need, this is going to use configuration information for the test. So I need a constraint there. And there we go. And we're already rocking our pair coding thing.
Yeah, multiplayer.
Using the generic law as it's been created here, which is awesome.
So does that compile? Not
We've
quite.
been working together some on something else, and we've used this as well as we've used a similar feature in IntelliJ, and it's really nice to be able to do that.
Oh, I think it's because of the environment. I think we might need to remove that. There we go.
Okay, so let's do test compile again.
And then let's see if we can just get an int schema, right? So there was the derived schema dot gen of int, or perhaps there's probably already an int schema, I'd assume somewhere. Maybe we could use our superpowers of posting on the ticket and asking John. How would I mean, obviously derived schema gen int probably works, but is there sort of like a grab bag of these foundational schemas that's easy to access?
Well, there are all the ones inside the companion object available for, they're mostly generic though, unfortunately. They're like tuples and eithers. And then there are actually ones for all of the primitive types.
So that's what we might need. Oh, so it looks like there's like implicit val, big int, big decimal. So is there like implicit val int? Or int?
You can summon one with primitive, I think.
Primitive. Implicit. Okay, so we can do. All right, so we can do primitive int, I think. Have you already tried that?
Oh, sorry, let me go back to you. I was lost amongst the code. Primitive int.
Oh, probably.
There we go. Okay, and that probably does the same thing under the hood as the derived, but that's nice. It's compiling. Okay, and let's.
All right, now we can run our test and have it spectacularly fail.
Yeah, let's see some not implemented errors pop up.
So I just do this. I just do this test only. I'm only going to run my spec, which doesn't. Let's see. Do we? What do we? Oh, because I'm not running the right name. ZIO.schema .generic spec. And we spectacularly fail because we have not actually implemented anything, despite having acted like we have. Yeah, and that like test only is nice, especially when you're working on larger projects. You can kind of only test what you're working on. All right, so then I think it's time to go back to generic here and work on implementing something. And so I think basically this is just going to be a big hierarchy that I think is basically going to mirror the schema hierarchy, except have the value inside it. And then these are going to be just like two big pattern matches that are just going to kind of convert one to the other. Does that make sense to you, Kit?
Yeah, yeah, it's should be relatively straightforward. Yeah, do you want to start just with that test? Just
Yeah,
do it.
why don't we try to just get this integer test working first? So this one, I guess I'm going to want to match on the schema. And so let's say it's a,
Oh, okay, too clever.
if it's a, is it a primitive type? Let's see, primitive type. Oh, no, this is, oh, hello. That's
Screwing you up.
no, I think
Okay,
I was just type primitive, yeah,
I see. Nice.
and then this I guess needs to be standard type dot int type. That seems promising. And if that's the case, then we.
Oh wait, this would be matching. Okay, so the schema. That's
I think we. So I think, but one thing I'm realizing we're missing is I think we're missing like we actually need the underlying value here. So I don't know, maybe this should be like private val underline.
well. Wouldn't this be an instance of this? Like if this is the type integer int, like our generic the
Oh
values
yeah,
would be in case
yes,
classes.
you're totally right. Yes, we should be matching against self, right?
Yeah, which would
And
just
then
be integer
this,
in that
yeah,
case.
I was doing the other way around. Yep, you're 100% right. So self match, if we get an integer, then we can just return right value. And then
However, we also need to make sure that we need to use. So this is where it's going to get slightly interesting, right? We need to use the schema because we're saying, do we need to use the schema? Because yeah, this is going to be a schema of int at the end of the day. So we need to make sure that these align and that the schema is also a schema of int.
right,
So that's
right.
going to be kind of interesting.
Yeah. So do we? So what if we maybe we want to match on? Well, first let me do that. So what if we do like self schema match, and we kind of match on each pair that makes sense, and otherwise maybe initially we'll kind of fail with some like incompatible type error, and we can work on having a nicer error message there.
Yeah, that sounds like a great first step. So yeah, you could add basically back what you had there. So if the
Right. So
schema
then,
is a schema of an int and you have an integer, then
right. So then this will
good
be
to go.
the primitive type. Yeah, maybe let's do the fully qualified just so we kind of keep ourselves honest here. Schema dot primitive type. Oh,
We can kind of think of this as like, I think, like casting or something, right? We're trying to cast, and when you get that cast error, it's because the value you're trying to cast to the schema.
So standard type. That's what I was.
Standard type dot int.
Int type. Okay, so if this value is an integer and the schema is asking for an integer, then we should return it. And otherwise, perfect. Okay, and if we want to test the round trip, we're going to do this. And so it seems like this. Let's see. So we've got a value.
Above, I'm going to just add a better error message just to log the current schema and the current value.
So it's a schema of A. So here, since at this point we already know from the types that this is an A, it seems like here we could just, I think, match on the schema. And if the schema says this is a primitive standard type int type, then we could return the integer with the value. And realize, yes, this is definitely not exhaustive. Okay, are we compiling now? We are. Okay. And so that's interesting.
Sorry, what just happened? I was
Well, I was just compiling here and I was just kind of noticing
Mhm.
from a type perspective, I mean, I think the schemas, maybe this is a nice thing about the schema, it seems like it's allowing us to recapture some type information. So
Oh,
at
totally.
this
Yeah, right.
point, we knew it was a schema A and a value of A, but then
It's
now,
always surprising when Scala's G80T support works.
yeah, hey, that's what I was going to say. Okay, so I think this should work. Let's try this.
Woo!
Okay,
Now let's try to break it so we're not false positive. Let's pass
okay.
in something. Let's pass in the wrong schema or something. Let's pass in any string or something. Actually, no, that's gonna type check here. How
Yeah,
can
we
I
need
do this stuff?
to. So yeah, we could generate a wrong generic value. Though I guess to do that, we'll have to have a way to generate. And oh yeah, so why don't we generate like a record and see if that fails?
Yeah, I think it might type check it here because the int is going to have to match the schema type. So we'd have to have like a faulty schema or something. Have to
Well, I
cast
think the
it.
generic doesn't have any type information. Oh well, with a round trip law won't work. Yeah,
Yeah.
but
Here, let's do.
if we just try to do this like schema dot from generic, and we just make up a random schema, then that should
Yeah,
work.
I'm gonna cast this to an instance of a schema event and see if that fails us.
Okay.
So what do we get now? It should be hopefully the left, I'm guessing, or no? Or where is it gonna fail? Maybe it's just a cast error and I'm silly. An implementation is missing. Okay, so
Right, we were matching on, and we definitely have not handled that case.
okay, so yeah, maybe, I mean, let's assume it works for now and just try to break it later.
Okay, I mean, this might also be a good time to like check in with our person who created the issue and say, are we on the right track here with what we've done so far?
Yeah, let's open a
Yes,
PR.
right, exactly. You open a work in progress, prefix it by whip, or actually make it a real whip that's impossible to merge. And you say, hey, how's it going? And then you wait, some number of days to weeks, hopefully not that long, until someone comes back and says, it looks great to me. You're on the right track.
Yep. Yeah, and you figure stuff out as you go along, right? Like we kind of didn't know if this was going to work, but it worked, and that this seems to be not crazy. So it's
Yeah.
kind of just like this
One
time.
feedback I would give if I saw a whip like this is make the hierarchy of generic consistent with the hierarchy of the
Yeah,
schema, just
I
for
was,
ease of maintenance, so people know where to put things and how to name them.
Mm-hmm.
and I think that'll also make it easy for the implementation, because I think it's some of this actually be relatively mechanical if we can kind of copy paste the hierarchy here, like swap it in to have the values, and then these are both kind of just pattern matching the same mirrors of each other in the two hierarchies. So maybe that's a good step here. If we go to the schema, and let's find actually all the, okay, admittedly, this is a little bit of a big file, so we'll scroll up. So, okay, so it looks like it's nicely or relatively nicely organized as much as it can be with having some of the optimization classes. So I'm just kind of trying to, oh, so these all extend case class, and I think case class extend schema. Okay, so these all ultimately extend schema. Now I wonder,
So you only have to support actually case class, and then you can convert that to a record. And so you really only need to support record. And this provides a lightweight way for library authors to support everything, even if it isn't super high performant.
All right, so let's do the same thing ourselves. So let's maybe copy these guys.
Yeah, and do you want to also nest like the integer generic inside?
Yeah, I think we should replicate the whole primitive type thing probably. All right, so I'm just going to copy these out, comment these out for what's kind of.
Carson said, "Come on, generate a schema of schema to derive generic."
So let's just look here for a sec at the difference between, so the record here has a map from strings to schemas, and here it just has a map from strings to generics. Okay, and like the enumeration has now okay, so this is interesting. Here it's got a collection, or it's just got one tuple value of generic, versus here it's a map, because I guess this is describing all the possible cases of the enumeration, versus this is describing, this is the one case of the enumeration we're dealing with.
Yeah.
So we may have to be just a little bit careful here of how we translate these. And then we had this primitive one, which had the standard type. Now, I guess one interesting question might be, can we just reuse the standard type here instead of having to like re-implement that part of the hierarchy?
Well, I mean, we need a value along to ride along in this. I mean, we can.
But could it be like tuple of like the A and the standard type?
Sure. Yeah.
Right, just so we like don't duplicate this, and that would probably make the maintenance easier, I think.
Yeah. I mean, we might sort of be able to do that with everything, actually. Maybe what if we just had a generic tuple that's just like, does that make sense? That may not make sense. But the schema on the left-hand side and then the value on the right. No, I don't think that makes sense.
That's just quite gonna do like for the enumerations, like the having all the cases versus having this one case. But so what if, let's just play with this with the primitive type. So primitive, let's say it had like a value of type A and a standard type of A.
Yeah, let's
see if we could implement our integer in terms of that.
Sure.
So then this is now going to be generic dot primitive value standard type dot int type. Let's see.
And now we might lose the the
Oh,
get.
oh, well, I think this.
Oh, it's a schema of A, generic of A.
Have, maybe we just need to. Oh, did we just? Okay, let's see if that works.
Yeah, that wasn't the generic.
Oh, sorry, I undo. This
no,
is, sometimes when you do the undo, it it undoes the other person's stuff too. So let's.
Oh, generic does not take type parameters.
Okay. All right, so let's see. Yeah. Okay. Found int type dot type requires int type any. So what if we see, is that going to work for us? Okay, that seemed to solve that. Then here, so it's a primitive type. Oh, because now we have two, so this needs to be, yeah, we just need to be a little bit careful with like, we now have two different primitives, and then this will be generic. So we're going from schema.primitive to generic.primitive, and then it'll have the value and the standard type int type. Okay, we're down to one.
Yeah, we might be able to make this very generic too, but I think it would probably be good to like knock out a few other cases.
Like here.
Yeah, now we're no longer.
Right, though I think that's potentially okay, because as long as we honor the invariant that we only ever create we only create valid primitive types where these two line up.
Shouldn't it be standard type A?
What's that?
Shouldn't it be standard type A instead of an existential? Not here, down now.
Oh, yeah. Let's see if that'll work. Thought we were. So then we get this error here. Pattern type is incompatible with expected type. It found a int type and it expected a standard type of any. Now is that because we?
Well, I think internally we don't know the type anymore. So it like our self doesn't have an A there. We've lost it, and it doesn't. Because value is any in here.
So this says if I define, let's see, if that work?
If we define like two typed value on, I think on each of the case classes, that would probably be fine.
Like here.
Yeah, I just think sometimes this is actually
Oh,
this is a good Scala tip because I know I struggled with this for a while. Like this is kind of the Gadget problem that we were surprised we didn't run into earlier. But if you have an existential type, meaning a type that only exists on one of these constructors, but is not like the 8 is only known within primitive. But if we try to implement two typed value on generic, which has no A, it just basically thinks that value is any there. And therefore, because the A value has to map to the type of the standard type and A is any, then it's looking for a standard type of any, which that is not any longer.
okay, so.
You're doing a type case, so you'll want to delete those and insert a type parameter A. If you want to do it that way.
Yeah, let's see.
The other way would be with the @ sign.
Right. Huh.
Won't that get type erased though? Unchecked.
Yes.
Minimalized, yeah. And then it's the problem of any again.
Well, no, you need to do primitive @ Yeah, primitive @ and then delete the type parameter and 2 underscores. Yeah.
I still think there might be the problem there. What I was suggesting is like leave this like totally unimplemented like that.
Yeah, yeah.
Then I think it'll type check on each one. Obviously, then we have to implement it on each individual branch. And why does it think there's no?
We need the schema, right? Yeah, we need a schema.
Yeah, yeah, and maybe that's too much work. I mean, the other instances that we could like cast it, or yeah, it is nice to have the type checking though.
Right. The other interesting thing here is we now kind of have the A appearing in 2 places here.
Yeah, this is a different A internally. Or not, is it? Yeah, yeah, it would be.
I would call that B.
Yeah, down there.
And then turn that to B if you really want to do it this way.
Yeah, I'm not sure we're going down the best road here.
And why is it sad? Oh, because now it wants a B and we have an A.
Yeah.
Well, that's because I think we haven't maybe pattern matched yet. And shoot.
I would delete that type parameter B. I don't think you need it. I think that should be schema A.
Okay. And
you don't know that, and that's an A. And then add 2 typed value to generic.
Sure.
Oh, it is. It already is. Okay.
Yeah,
but
so yeah, just implement
it. It has the type parameter on the initial implementation.
Yeah, that's because this needs to know that.
Oh, delete. Right.
Yeah, because we don't. Yeah, because generic is untyped. It's definitely a little strange. Yeah, we're just not going to basically. I mean, the whole point of this, I think, is that we don't have a type, so we might not have type assistance. I guess we got it initially.
Yeah, I mean, I think we could either go back to where we had the types at the base level, or I mean, I think it was sound to do that cast up here.
I would delete 2 typed value, or delete the type parameter. Sorry, in there because you can't know anything about that A, so it's equivalent to an existential here. Oh no, it's not.
Yeah.
Because you do have that top level, it appears in the return type. So yeah, it needs to be there.
Yeah, I think we
I
do.
think you have to. I think you have to do a cast, or at least it's going to be convenient to do a cast.
Yeah. Okay. So let's go back to this. Let's maybe remove this guy. And so then I think we want to, let's at least, I mean, maybe we can, let's say
Oh,
we're,
I would still introduce that. I think that's correct because that gives you a little type safety.
okay,
Now implement.
yeah. Okay, so we have schema, oh, yep, okay, that'll fix that. Okay, so now, yeah, let's get rid of this. I think we don't need that. So this will be value, and then, oh, we wanted to call this primitive type dot int type, right?
Mm-hmm.
Mm-hmm.
And then,
And this it doesn't like.
Yeah.
yeah, so then I think we could do.
Convinced this can't, if it's convinced it can't be possible. It can't be possible to match against this. That's because it's failing to track A.
Yeah, so that's why I think we.
What if we just do, actually, what if we do the primitive in here? Let's call this P. Does that work? Does it not like anything in there? Not found. Is that delayed? I'm still seeing an underscore there. Is never used. Okay. And what if we do in here like P2? Because like ideally this should already be correct by construction. And then in here we can check to see like if P is equal to P2, and then we can cast it to any instance of A, ideally. I don't know. It still seems to be. There we go.
Let's try compiling this. Maybe. Okay. Yeah. Get rid of that.
Why was that? Oh, because we're already in schema.
Right.
And then yeah, well, let's try running the test too, and if that all works.
Let me just. I think we're slightly behind on compilation here.
Gotcha. Because that might be nice, is that we can sort of.
Then they'll handle all the primitive types for us at once if we do that, which should be really nice. Oh, okay. Well, I tested everything, but should not do that next time just for speed. But yeah, so it looks like that's working.
Nice. So now we could really just try it with other things.
Try it with some other.
Would this be possible to do in other ways? So primitive int type, primitive value. I mean, I think we kind of do the same thing as well here. Maybe not. Because there should only be a single one per, there can only really be an implementation of this, right? I think we have the same, we just do anything. Because it's going to be the type based on the type of primitive. So now we could try it with like strings and stuff. Let's just add to our test.
Spec, yeah.
Which isn't, yeah. I wonder if we can make this whole thing as short as that as well. Aha. I'll add some more below. Let's get a bunch of other types. We could probably even just make a list of schemas. Actually, let's do that. Schemas.
Eventually think about getting super generic and just generating random schemas. That would be another interesting level here.
Yeah, anything that is of a primitive. Oops. Well, yeah, let's do it this way first. We can
do a couple of them here and just okay.
So string, Boolean. What else have we got?
Float.
Floats. Cool. Why is that not formatting? So, oh. So I'm just gonna ding, 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 string. Oops. Ding, 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 Boolean. And then I think he said float. Oh, oops, float. I'll just call this schema, so to save the naming of all that stuff.
Fair.
Nice. Is it all happy? I can't, it's not formatting for whatever reason. So there might be a.
Let's see, we're probably, I think, just messed up like a.
One too many S's on schema on line 22.
Schema. Yeah, now we have so many. This is great. Like we have 77 people to spell check us.
Yeah, exactly. Okay, so
And comment on your indentation. It's a crime that line 24 even compiles. If I designed a programming language, it would not compile.
I don't know why it's not auto formatting. I think there's still a problem on what 15. It says expected a semicolon. No, never that. Have I done something evil above? Oh, this should be a. That should be there. Okay, because now we have multiple. There we go. Nice. Oh, okay. Oh, there's not any Boolean. Oh no. How about one of? Is that work?
It's just Boolean.
Oh, it's just okay. Any Boolean. Only true Booleans.
Okay. So look at that. That's pretty cool.
Yeah. I mean, what we're doing is probably, if you think about it, pretty silly. But no, it's nice. It's certainly not much code. I wonder if we can extend this to something higher level.
Well, I mean, I think basically I mean, there's a little bit more, but if we just do like the record and the enumeration, that like is theoretically like almost everything. So should I try to do one of these?
Which one? Sorry.
The record or the enumerations.
Yeah, let's do record.
Okay.
If we make a record of primitives, and I think that would be like a good, if we can accomplish that, that would make me happy with this session. We would have.
I think that's a good goal. Okay, so let's follow our same pattern. So if this is a generic dot record with some values in it,
Mm-hmm.
and then we would want this to be a schema dot record. And the schema dot record, if we look at that, that's a map from strings to schemas. So I think we're almost basically just going to want to do this like recursively.
Yeah, just kind of zip them together and then recurse.
That's a map strings. So let's just call it
Schemas to match values and schemas, and then we zip them up based on keys.
Uh-huh.
I'll just, oops, sorry if I stole your cursor. Just wanted to do that. There's a bit of Three Stooges action going on when you do VS Code live share, but it's mostly, I think, pays for itself. And then I hit save and I auto format away as lines. So
no, it's fine. So yeah, so it seems like the first thing we do here is we need to make sure that these have compatible shapes, right? So like maybe we want to do something like if values dot key set not equals schemas dot key set, then we just want to fail. And I'm sure we could do a more helpful diff, but right now maybe just.
So I wonder if, I guess, yeah, if something's optional, we would want the none record in that case. So that, yeah, that I think this is a good thing to maintain.
Yeah,
we have the choice to maintain that every key is populated. I think.
So otherwise, we know that's the same. So then we could do something like keys values dot key set, and then basically going to want to fold over the keys. And so ultimately, what do we want to return here? We want to return.
Well, I think the A. So, Oh, that's interesting. So yeah, we want to build the A, which might be, This is some record component. Does schema have a method for, does the record have something in it that we could use to construct the A? Because I don't know if we know how to do that, unless it always maps to a, what is the type of A for a record? Is it a tuple?
It would, seems like it would be a tuple-like thing, yeah.
I'm just gonna poke at this schema here. Let me copy this. Oh, it literally, okay. Oh, this is easy, okay. or it's not easy, but here I'm going to paste this in above. This is the, so yeah, we want to return our A in this case is going to be a map from string to whatever the value is. So we want to build a map. So we could start with an empty map then, if that's our return value. Map.empty of string to underscore, because it's going to potentially have multiple values in it. So nice.
Okay, and then this is going to give us the map and the key. And so we'll do value equals values. At this point, we know all these exist, so I think we can safely apply that. And now schema is equal to schema's key.
And then just call toType value recursively on the.
Right, I think that's right. Value dot toType value schema, and I think the only thing we're missing here is we're gonna have a possibility of failure here. Right, because this could return us an either, and so I think we want this to be something like a right of a map.
Yes.
And then I think we'll need to specify the type here, because otherwise it'll be too narrow. So this will either be a string or a map from string to, I think we just call it any.
I think maybe then we won't need that, just to save some horizontal space.
Yep. Okay. So now we can match on the value to type value, and it's either a left or a right.
Well, actually, I think coming into it, our map is actually an either at this point.
Yes, you're 100% right. Yes. So maybe we should actually change this to like a pattern match. So we could say this is either a right or a map. And we could probably be more efficient here because I think this is going to traverse the whole thing regardless of whether there's been a failure. So we could probably do some more short circuiting, but we can come back to that. So then, or it could be a left. Maybe this will be good because it will accumulate errors.
Oh, sorry, I hit undo, and I've misformatted everything. There we go, auto format, thank goodness. I might actually also just, if you're okay with it, change the, just so we can get rid of this else, we can delete that, and then just put the if on that side, and then basically do that.
Yeah. I think we formatted while we're working, so I'm just going to copy all this and close this and paste it back.
Oh, did something happen? Okay.
I think we screwed ourselves up a little bit with formatting, but that's fine.
Nice.
Okay.
Someone said Prelude would come in handy here, and I was thinking that myself. Yes, this is one of those other cases, if you watch our, which should be posted, I think, tomorrow, I've been told, the Prelude session. This is one of those, besides validation and semi-groups, folding over an either structure is yeah, this effectful fold is a little annoying. Especially if something like Prelude can take care of the early failure short circuiting capability.
All right, so if we got a value back, then we just want to do map plus key to value. I want to just pause error. Okay, so I think this, I'm not sure why we're getting the, okay. Found.
I might just rename this nested values to generics, just so we can separate the word value from generics. And then call this a generic as well.
Yeah.
Generic to type. There we go. Okay. And then, did I do that correctly?
Okay. Let's try compiling this.
Oh, we're never using record? Okay, we're never using record because we just have the schemas that are, so we don't need that.
Well, at least we're down to the warnings of not using things.
Okay, renamed everything.
Okay.
Okay.
By compiling this. All right.
Okay, now let's test it. then we got a PR in our hands.
All right, so, oh, you want to do this? Sorry, I think we're going over each other.
Oh, I'm in a different tab. Did I screw something up? No, it's okay.
Should we write a test for this?
Sorry?
Should we write a test for this?
Yeah, totally. Yeah, round trips.
So I'll just copy this and start from there.
Yeah, and then we can maybe have a particular case.
Okay, yeah, so this needs to be a schema. So what would,
Let's make one of those examples. All right, case class. Let's do a person or something that just has primitives. I guess it could also have nested values as well. Oh wait, this would have to be of a map. So yeah, right now we don't have the idea of mapping involved. So let's do basically it's a schema of a map that goes from nothing to
a string, right?
string to anything. Yeah.
Okay, I'm guessing there's a schema dot record.
Yeah, maybe this would be.
Oh, so this would be like a, this will be a, so this could be like a map name to standard type. Standard type dot string type, and then age to standard type dot int type, right? I think that would be a valid record.
And then we'd sort of need to make our own gen as well for this thing, and we can make it of the. So yeah, how would we do this? We want to get a name, so this would be gen dot any string, and then an age, which is a gen dot any. Would you make it an int? Nice. And then we can make ourselves a map from name to name and age to int. And yeah, we could probably totally self-host this and use schemas to generate these things. And so there's a schema, and then we want to record.
This needs to be schema dot primitive.
Is that right? Okay. Yeah. Yeah, definitely might be nice to. I mean, most of the time, I guess you're going to auto derive this stuff, but yeah, maybe this is also an opportunity, I think, to think about. Oops.
Yeah, sometimes the tests are a good place to see your API in action.
Yeah, exactly. And oops,
that is correct. So we just need to type that, right?
Oh, yep, totally.
Okay.
Okay. Let's test it.
Oh.
All right, nice. A failure. Okay, that would have been too easy. Too easy. What have we done?
Not implemented.
Oh, we didn't do the. We only did one way, I think.
Oh.
Someone probably posted this.
This is normally I feel like I'm better at like responding to comments, but we're kind of in it here. Okay, so if we have a schema dot record that has this map of schemas, then that needs to be mapped to a generic dot record. And then we need to, isn't it basically like schemas dot map values? So I guess we're not supposed to use map values anymore.
And I guess if it needs to be cross compatible, we could just do map and then just reuse redundantly.
Yeah.
Key, and then what is the? Oh, it's the value, right? Or this would be the nested schema, and then go there. So yeah, what are we doing here? It's curse, I think, right?
Yeah, so I think so in this case, this only makes sense if the value itself is a map, right?
So wait, we have a, what is this?
So I think we basically need the same thing.
It won't be a map.
Oh,
it won't be a map necessarily. It could be an arbitrary user case class. And if that's the case, then, I mean, in this case, that's true. So if you have a record, it's when you hit transform that you might, there might be a map behind it.
Right.
In this case, it has to be a map.
Right. So we know, even though we don't know here that this value is a map, we know down here it's a map.
Does it think that it's a map? If I say value map equals this, can I get the, I could type ascribe it. It should be a map of string to anything. Will it yell at me? No. Okay, perfect.
Okay, that's cool. So then
we
I think we basically need to do like the reverse of the above, where we need to see if they have the same keys.
Mm-hmm. Well, oh yeah, true, because it could fail.
Yeah.
On line 37, that should be a schema underscore, schema wildcard.
Oh, gotcha.
Schema wildcard?
Oh, yeah.
Oh, is it? I think that's what's in the map. I think this is the value, so it's what the value's type is.
Oh, right. It's okay.
Which is just an underscore. It could be any value.
You're right.
Yeah.
But yeah, it may not be in the map. So yeah.
But I think you're making a good point though, because this needs not return an either, but needs to return a generic, and we should statically know that these two things have the same shape. So I think you're right. We don't need to do the check of whether the keys match. We can know that they match.
It could blow. I mean, I think as long as you generate it the right way. But yeah, anyone, obviously, because this value is a map from string to anything, it could potentially blow up. So maybe that's a thought to have, which I think can also happen like in the implementation of a sort of a high level issue. Like maybe there's some more complexity there that you discover, and then you could bring that back to the PR. Like, what do you think, John? Should this potentially, PR comments, should this potentially be failable?
I think that if it fails, it's because there's a bug, and so you should just blow up. It's a defect.
If the schema is valid, then its shape needs to match.
Yeah, and right now these constructors, I don't know. I guess we're leaving them open, just sort of under the assumption anyone who works with them is operating at a very low level, and they do have the ability to do unsafe things.
Right.
Oh, and then that's not happy because it doesn't. Yeah, now I think is the point where this can be any schema and it's not any. So we might need to say like, okay, you could be anything.
Well, I mean, this is kind of funny when it says found schema of some existential type required schema of any, which I guess it's invariant. So it's, I think, sound, but yeah. Well, so what if?
You need to cast map key to the same type as the schema that you have. So how you can do that potentially is in line 39, add a type annotation to schema. Say that schema is a schema of some unknown type, but name it called A, lowercase a. Now this becomes an existential type that's named. And then when you pull that value out of map key, you can add a dot as instance of little a.
Oh, little a.
Oh, that's lovely. We're like picking up some advanced type level programming here.
Uh-oh, exhaustivity check analysis reached max recursion depth. Not all cases, okay. And then we'll just return whatever underscore, there we go. All right, now let's test it. Oh, you're already doing this. Congratulations.
Hello. All right.
Hooray.
Well, that seems like a lot of good progress for a session.
Yeah, that was awesome. I think most of the I mean, it's just going to be sort of building on this pattern. So
yeah, I mean, really, the enumeration is the only other fundamental one, and I think now we've done records.
That's right.
That out. So this is very cool.
Yeah. So
that's awesome. You're almost there.
Want to open a whip?
2 hours of work.
Yeah. I mean, yeah. Oh, yeah. It was 2 hours. I mean, the first half was speculating and waxing poetically.
Yeah. So let's go back to this. So at least I often will give names just based on the number of the issue. I don't know if that's what I do. I don't know if that's best practice.
That's great. It is.
So I will create a branch 36 for that. And maybe I'll say, well, let's see. I think I've got some stuff that's just my own settings here. I upgraded the SBT version, so I'll leave that. And I'll leave these guys. And so let's say,
6 characters over. It's
all right.
unreal.
And I'm just gonna, let's format this. If I like thought this was gonna be final, I would like do MDoc, and depending on the project, there's some other stuff, but I think we know there's a lot more to do. So we're just gonna get this out there to have something.
But yeah, also don't worry about, I think maybe some open source maintainers might be frustrated, but I don't think I've ever experienced that in ZIO world.
If you've got good functionality in there and like all I have to do is be like, hey, can you run format? Like that is a great position to be in.
Yeah, yeah.
All right, so I'm just gonna push this up, and then maybe I'll go back here. And so usually there's a nice helpful thing of it just says branch had recent issues. So I'm going to do this, and we'll do this draft pull request.
Oh, nice.
Yeah. So let's say implement. All right.
To maybe tag the issue as well.
Yeah, exactly. What was, and there's always helpful to me because I have it's right there, so I know it's number 36. So I don't have to look it up again. Let's say
fixes 36.
Includes implementation of
nice. Cool.
you. Give you that.
And all the other 70 people who watched. Let's get them.
Exactly. And let's see. I wonder why I can't. Do we have some? I don't know why we can't automatically merge, but let's go with what we got. So let's submit that.
Maybe there were some upstream changes.
Maybe.
Or maybe it's because you're like a first time.
Oh, yeah, I don't know why.
That was me. Sorry.
No, that's fine. That's fine.
Working in the background.
Did you push that or else either change?
I did, and some other stuff as well.
Nice. Okay, so there we go. It's not. I mean, it's not quite ready to be merged yet, but we did our pull request here.
Hooray!
So,
Yay!
Yeah. Thanks so much,
you.
John. I mean,
yeah,
any sort of final thoughts? I hope everyone is like sees that the process isn't hard and obviously we were able to sort of cheat and get instant feedback from our comments, but pretty responsive community, and I think as John mentioned at the beginning, like I'm way less busy than some other people as well, so I'm super happy to offer like pairing if you want to work on some of the stuff I'm working on. We're going to show off some other cool stuff at next week's Symposium, probably, that we've been working on around on a new assertion framework for tests. Maybe not next week's Symposium, but eventually. There's all this stuff going on that's really exciting. If you're curious and want to, like, you feel passionate, you want to hack with us, we could do something like this. Join us.
Yeah, please do.
Yeah, 100% happy to as well. And I think the other thing you could see is like we made plenty of like missteps along the way there of like we kind of tried a different approach, like with the way we were doing that implementation of the subtypes versus the parent type. We're kind of like, this wasn't working. We kind of came back and we had lots of like little things where like we didn't have the types lining up. We're making typos. So like I think it can be easy to like feel like nervous or bad about kind of other people seeing code, but we all make plenty of mistakes.
We're all there. There's no judging here. We all make mistakes. We all hit dead ends. Doesn't matter how many years you've been working at this. That's all the same.
Mm-hmm. Especially with Scala2's types system, so which is beautiful as well. Yeah, thanks so much, guys. We'll hopefully can do this again sometime, maybe with a different open source library or still in ZIO Schema. That was super fun.
Yeah, thank you so much, everyone, for joining us.
Cheers.
Yes, absolutely. Thank you, everyone. Thank you, Adam and Kit, for putting this together and inviting me.
Yeah, thank you so much for joining us. It was really incredible.
Anytime.
All right, bye-bye.
Bye-bye.